Hello and welcome to this video on design script and autocomplete, which is a feature of the IDE, this design script editor, that makes predictions on the code that you're writing to help assist writing code. So if we import a library such as the geometry library, autocomplete will begin to give suggestions about constructor and method names when we begin writing in the names of objects. So here, as we've previously seen, point has a variety of constructors that are suggested by design script when you begin writing the word point dot. So here we might choose something like bicylindrical coordinates, which is a means of generating a point on a cylinder. So after filling in that suggested constructor name, if we type the open parentheses, design script will show a list of parameters and their types that are required to create an object. So coordinate system is the kind of underlying kind of axes and scaling and rotation that might go on with the point. And we similarly have radius, theta, and height. So the name of the actual parameter gives a suggestion as to its use. The colon symbol separates the type of this input argument. So here we can see context coordinate system is fairly obvious, is a coordinate system. The radius is a double, which is a type of number, a number with a decimal point. Theta is the kind of rotation along the bottom radius. And then finally, height is the actual height of the similar. And all of these are doubles, as you can see. So in other words, floating point. So we can fill this in. Some numbers. And now generate a point on the cylinder. So another handy feature of the design script editor is a means to step through code. So again, I'm going to copy and paste some code from the manual for brevity's sake. Which, when we run it, revolves a point around the actual, revolves a line to generate a hyperbolic paraboloid. But if we hit the debug button, we can actually step through and watch this form generate one step at a time. So here we can see we're generating one point and then a second point, and then using these points to generate a line. Here's a line. And then revolving the surface to create the hyperbolic paraboloid. So this is useful both to kind of get a better understanding of how a piece of complex geometry in a given script is actually generated, as well as to step through one line at a time to discover bugs that might occur in your program. Thank you for watching.